All right, let's get started here. Hello, everybody. Welcome to this episode of BlockChai and Chill. I have with me Jonathan Ashili. We'll start off by introducing ourselves in a little bit. Today's topic is about essentially comparing the authentication in Web 2 versus Web 3. So I'm the co-founder and CEO of Decentology, a fellow geek, love to develop, write code, etc., and love to share about it with the community. So today's session here is an opportunity for us to kind of compare and contrast Web 2 and Web 3, and for you to ask any questions you have about it. So the protocol we'll use is basically, if you have a question, please put it in chat. I'll be reviewing it periodically, and we'll take some of those questions and potentially also, time permitting, invite some of you guys to have a more interactive discussion about those questions. And now I'd like to introduce you to John Shealy. Please tell us a little bit about yourself.
Sure. Hi, I'm John. I'm the senior architect at Decentology, and I build applications and everything from our hyperverse to our websites to anything that needs done, basically.
That's great.
And I guess a little history, it's been a developer in Web 2 and Web 3 for the last like 30 years.
Wow, that's a lot of experience. That's amazing. All right, so let's just get right to it. Why don't we start by first talking a little bit about what we have today, essentially Web 2, and tell us a little bit about the authentication model, and then also potentially the authorization model about it.
Sure. Yeah, I was even going to step back maybe even further than that. There was a great tweet by Gabby on our team that had an illustration of where we came from Web 1 to Web 2 and Web 3, which is essentially Web 1 was usernames and passwords. Web 2 has mostly become an OAuth provider model where you log in with your Google or your Microsoft 365 account or Facebook or GitHub, to now Web 3, which is your wallet providers. And we'll get more into that then. But ultimately, through that process, we've learned a couple of things, and the biggest thing we've learned is authentication is hard. Doing that at scale and across different environments where you have single sign-on and all kinds of real world use cases other than just a website. So going through that, we've learned that honestly the user containing their authentication is the best, because they're going to take it with them wherever they are, and it's the same one that they would use whether or not they're logging into a desktop application or a web application or their phone. It's the same login everywhere, and it's something that they own, and you don't have to worry about connecting to a third-party service.
Cool. And what were some of the biggest challenges that people experience in that model?
Yeah, I mean, first and foremost is, we hope Google never goes down if you're ever logging into that, but they do. So if you're ever using single sign-on with Google authentication and they're down, you no longer have access to any of your resources, whether or not that's, how you logged in with GitHub or anything like that. If those services ever go down, you're kind of out of luck during that time period. Versus in the old days when you logged into a specific website, as long as that website was up, you were good to go. And then the other thing that happened is they essentially would aggregate, if you're using Gmail or anything like that for your authentication mechanism, they contained all of your data. So whatever is in your profile, your first name, last name, email, and any of that extra data that comes along with your profile, they controlled, and then they could, give out, and you would update it from there, versus kind of you owning it and then deciding at a per application layer, who got to see what.
Yeah, I mean, in that scenario, like, it's not just about the data, right? It's also about tracking your behavior at every site where that login is used and what you do there.
Yeah, I mean, so I always look at it from like the developer point of view, like trying to build that and having all those integrations with each of those systems. Like you're trying to do it on my website. At the end of the day, that's all that matters. I just want people to be able to log into my website. So now you're beholden to another system to be able to do that and properly, go through that flow. And then you hope that everything's working on their end to come back to you and say, yep, they can log in and here's the data that they're going to provide. And you never know what that's going to be because every provider could implement that spec differently. And the spec we're ultimately talking about for Web 2 is the OAuth spec. Which has a very specific profile of information that they're going to give you, but specific in the sense that they're going to say email, but maybe that email for developers is an array because they might have multiple email addresses like aliases and things like that. So then your application has to cater to all of these different standards just to hope that at the end of the day, you get their email address so that you can contact them or set up an account within your website.
All right. So in the world of Web 2, this authentication happens, whether it's using email password or OAuth, etc. The owning website essentially is communicating and with the login provider, whether that's Google or Facebook or whatever, and they say, yep, this user is authorized, and here's a little bit of information about them. They give it. But then what about sort of permissions, authorization, as we call it? What happens there? Does that still happen with Google or Twitter or whatever, or is that something different?
Yeah, so we always separate kind of authentication and authorization. They're two, different things. Google handles the authentication for you, like who is this person, username, password, login, so that you don't have to maintain that on your website, which is something we've learned through the Web 1, the Web 2, which is we don't want our passwords on every single website around the world, because things happen, websites can get hacked and things like that. Now your passwords everywhere. So we've learned, okay, let's use different passwords. But even easier is let's just store that in one place like Google or Facebook handle that. And then we log in to our system. But at that point, you've passed authentication and now you're in authorization is what do you have access to? And that's something that your website ultimately controls through a role-based system. Now, in the real world, that gets more complicated because of like a single sign-on process. Like businesses, you would want to be able to set an authorization potentially at that authentication, like one more hop before it even gets to your application. So that way you say, this particular user is a manager, an error manager across all of the applications that they would use because you don't want to have to dictate that inside of every single application. Be like, okay, in application A, he's a manager, in application B, he's a manager, just say at the higher level, he's a manager. And that role would, proliferate down through each of those applications. And that's where the authorization step kind of comes in. And that's where things kind of get, again, authorization and authentication is hard because, everyone has different use cases. Big businesses have different use cases from just your, website to, host your, baking challenge, something like that.
Okay. All right. So we've covered Web 2 here. And what we've understood is that there are a ton of moving parts here. There is the actual website where you're authenticating. There is potentially the provider, the social login provider. Then amongst all that, there's also additionally this layer of roles about what you can do based upon that authentication. There is this concept of profile data, which you don't have any control over. Both the website owner and the social login provider, they decide what happens. And you are like, yeah, whatever. If you say no, then you can't use the site anymore. They're like, okay, fine, but you can't use it anymore. So that's Web 2. We've got that. That works right now. It doesn't work like it works in terms of people are able to use it, but is it the most safe? Is it the most secure thing? Is it the most private thing? The answer is clearly no, given by all the headlines and all that. That's just a rhetorical question. We know it's not, right? Okay, so now we have Web3. It's a whole different world. We've got no central servers. We don't have a Google. We don't have a Facebook or Twitter, etc. We have these blockchains, and some of them are in their infancy. So they are quote supposed to be decentralized, but if you've got only 5 nodes, that's not really decentralized. You can shut those down and they're gone, right? But let's talk about a more established kind of blockchain like Ethereum or something like that. They've got hundreds of nodes, maybe even thousands. I don't know the last count. In that scenario, clearly the sort of infrastructure is decentralized. You can't shut down one of those servers and login stops or authentication stops. But how does authentication and what is the model of authentication in this scenario? Let's talk specifically about Ethereum, and then perhaps you can talk about a couple of others then.
Sure. Yeah, and that works great. In the Ethereum model, I really enjoy that now we have switching between signing with the username and password. That's now gone. We no longer need, as you mentioned, the big providers, so they're gone out of this equation. So how do you log in if you don't have that? At that point, we go back to some more standard things that we've and have been using in the system, which is public-private key encryption. Every computer in the world is already doing this. This is how SSL, TLS, HTTPS, that's how that system works, is the same concept. So it has been around now forever and we've adopted it. It's like, this is the way. So, but we've never used it as much for our personal websites. Only kind of developers will ever use it. If you ever log into like GitHub or something like that, they'll ask you for your private key, and that's how you would first, sign in. Then you never have to deal with the password anymore. You just have your private key and you sign. So now we've taken that kind of concept for blockchain and now put it into what we call now these wallets. So you have your private key, and then you can then share your public key. And then as long as you can sign something, you'd be able to sign into the website. The nice part about that is, like we mentioned earlier, is now that flips the script a little bit. Now you no longer need a central authority to authenticate. You can authenticate by yourself to that service, and every individual now controls their authentication, which is like amazing, both from application. So if you're ever doing offline authentication, so if you're traveling, you're on an airplane somewhere, you can still log into your application. So if you just need that extra like security on your laptop, you'd be able to sign in. You can then link it to other devices, which we'll talk about more later, but actually being able to log in with your phone, because your phone can control that private key into your wallet. So therefore, anything that uses like what we call like a 3-legged authentication can use multiple devices to actually prove that you are you, but you get to control all of that without having to, contact any third-party service if you don't have that.
Cool. So I understand that a little bit, but I think, we use a little bit of technical terminology, etc. And I want to take a step back a little bit, and for this audience here, talk a little bit about what some of those things mean, and then we can continue our conversation around the authentication. So, John talked about cryptography, public and private key cryptography. I mean, essentially, this is the basis of most of the secure communications that we use today in just about everything. And the basic concept is that there is some complex math involved, which results in essentially the first and foremost is a string of numbers and letters. You can call it that for simplistic purposes. That's called a private key. You're supposed to keep it secret, hence the term private key. And derived from that is something called a public key. And that's also a string of letters and numbers, but that you can publicize to everyone. And the basic concept behind it is that the private key can be used to sign a transaction. And signing is essentially saying that taking any piece of information, whether it's a number, it's a message, it's a file, anything like that, and creating something called a digest from it. A digest is taking all that information and compressing it into a little bit and then validating that. And the purpose of that is to allow anyone in the world who has access to your public key to verify that you, in fact, are the owner of that private key, because you are the only one who could have signed it. If you don't have that private key, it is not possible for that public key to validate that as coming from that private key. So private and public keys are sort of the two two parts of the equation, and they form the basis of almost all of this. Now, what John explained earlier is about wallets, etc. Now, I have been on the record many times in public talking about how I really dislike the term wallet because it's poorly named from a user experience standpoint. If you think about a wallet, generally people think about it's something that contains money or etc. But when it comes to Web3, our wallet is really nothing more than a collection of our private keys. And in many cases, that wallet is also a tool that does the signing I just talked about. So a wallet never ever contains anything. Like people might think, oh, my wallet contains my crypto, or my wallet contains my NFT. Here's the fact. Your crypto, your NFTs, etc., they're always on the blockchain. They never ever actually physically are anywhere in your wallet. Your wallet is just a tool with a collection of your private keys. And so as long as you have those securely, you can then sign transactions. So a lot of people panic when they, for example, lose their wallet. Maybe their MetaMask crashes or something like that. And they're like, oh no, all my crypto is gone. My NFTs are gone. Well, not really. They're all just sitting there on the blockchain. Hopefully you backed up your private key. As long as you backed up your private key, you can just have access to all those assets. Again, it doesn't matter. You can concurrently use MetaMask and any other wallet, Rainbow, etc., with the exact same private key, and it makes no difference. Because remember, like the important thing to remember is that wallets are simply collections of private keys and a tool to sign them. They contain nothing. So you can concurrently, for your account on Ethereum or any blockchain for that matter, use as many different wallets as you want, and it makes no difference. They're all the same. So I wanted to make sure that we kind of set that baseline, because once you get that, then you understand that the main thing you need to do is keep that private key safe somewhere else. The wallet, etc., you can delete it. It doesn't matter if it's gone. You can reinstall it, re-import the private key, and you're back in business. Your wallet contains nothing. All right. So we've talked a little bit about sort of MetaMask and Ethereum. So John, can you walk us through the life cycle of changing information on a blockchain? And maybe it's as simple as sending money. Maybe you're sending me some cryptocurrency. What's going on there?
Yeah, so ultimately there's a transaction that says, I'm trying to send you $10. That gets set up as just a simple object that says, my address, your address, $10. So now in order for me
I would like 10 ETH, not $10.
Yeah, 10 ETH. Yeah, 10 ETH. So that would be substantially more money. So that is much better. So we're going to send you 10 ETH. But if I were to just put that out there in like in typical Web 2 world, that's a transaction to an API. That API, I just put that address in there. That's my address, but how does that server know I'm the one that actually did it? It had to go through some authentication system. Well, that website is the one that controls that authentication. So if there's a compromise there, then the whole system is busted. That if that authentication ever gets compromised. So instead of doing that, we use that private key in my wallet, which is something I have. So I've now signed that object that says with my private key that so it encrypts that message. But now when that message gets sent, it knows that I'm the one who sent it because of that encryption there, and it can be approved by looking at the public key for my address and saying, yep, okay, John sent this to Nick, and therefore it works. That transaction now is put into the blockchain process, and then that's how the gears work. Someone grabs that particular message, puts it into a block, signs it, and that's essentially blockchain technology at that point. Yeah. But the authorization part, I think, is particularly interesting when it comes to that signing process, which is, we again in the Web 2 world, right, is order something we have, which we use the term like 2FA, two-factor authentication, or like a one-time password, because you start with something which is username and password, but now you don't need that because you have your address. That's the thing and the thing that you have that skips 2FA now is your private key. You have that on you at all times, so it's yours. So you don't have to worry about 2FA processes or one-time passwords. And if you want to protect it, you could still use Face ID for phone and mobile to be able to do that signing process for you, to guarantee that it is you and someone didn't steal your phone, which has that key on it. So you can use that kind of a process to kind of give you the benefit of something you are, something you have, or something .
Okay, cool. So I see a couple of questions there. So one of the questions is, if you if all the assets are on the blockchain and you lose your private key, is there any way to access it? The answer is always no. If your private key is gone, you're done. I mean, I'm very sorry. It's very tragic, but there is absolutely no way using current computing resources that we know of. Maybe state actors like the NSA, etc., might have something, I don't know, but for all practical purposes, it is done. You cannot do anything with it. So the follow-up was that as well, if they're always on the blockchain, isn't there some way for you to prove that it was you? Now, here's the thing about blockchains. In order to write or change information, you need to sign a transaction, which requires a private key. But to read information, anyone can do it. There's no transaction. It's infinitely possible. As long as there's computing resources for you to be able to read, you can read it. Now, if it was your NFT or your collection of NFTs and you've lost the private key, the world still knows that that collection of NFTs belongs to address, ABCD or whatever it is. But that's it. The game ends there. There is nothing more that can be done. The whole point of decentralization is that there is no central authority. So there is no forgot password. There is no one you can reach out to say, hey, please help me, recover my private key. Now, this is why it's so important that you keep your private key very secure, backed up, etc. Because once it's gone and it's irrecoverable, everything about that account is frozen in time, frozen with the last transaction. You cannot change it anymore. Now, a smart contract, for example, might be able to do something that it has already authorized, or you have previously authorized, but anything beyond that is not possible. So yeah, that is a very bleak and tragic scenario if you've ever lost your private key. So let me back up a little bit and tell you
I was going to do the on-ramp of that process. So
let's do that.
Yeah, so when you first start with MetaMask as an example of a wallet, and there's many of them that we'll go through and talk about some of the other examples of them, but that one fundamentally works on your phone or as a Chrome extension or Firefox extension. So when you first install that, it's going to ask you to save a series of mnemonic words that it uses, but that's what it uses to derive this private key for you. What's nice about that is that it's just a bunch of words that you can save, but that's why all of them ask you very specifically 1,000 times, did you save this? Are you sure you saved this? Let me ask you some of the words of the ones you saved, just to make sure that you saved it and you didn't pass through this, because this is super important. So some of them are a lot more problematic with how they display the words, and you make sure you have to count them up yourself, which is a different exercise than making sure you save them, but I digress. But that's what that essentially mnemonic gives you. All those words are to generate private keys for you, so that way you can have multiple keys and multiple accounts for yourself, but going through that process. But yes, once it's gone, it's gone. In a current state of transactions, to kind of switch gears just a tiny bit here, to hit on one of the things that Nick had mentioned is, yeah, currently an NFT, the way like 721 contract works is I own my NFT, it's transferred to me. But in decentralized world right now, we are saying that there is no authority that can then do something about it. If I lost my private key for whatever reason, I had it on a flash drive and it fell in the ocean, that it can't be recovered. But there's nothing stopping future contracts or our contracts, as Nick had mentioned, that we eventually do trust somebody else. We can have third-party arbiters that we say, okay, I'm going to give you access to this. And if something were to happen, we all trust you to protect that and move it into a new account that at some point, maybe you call up someone and we're like, yep, you are who you say you are. We proved it for some other way. Maybe it's a week-long process of you proving who you are, but then they could transfer that out of the address for you and put it into a new account for you. And then everyone who's using that contract would be able to see that and understand that there is someone who has the authority to be able to do this, but we're trusting that person in that account, and we can monitor that they're using it in good faith because the transactions are transparent on the blockchain.
Right. Yeah. So I just want to elaborate on a couple of things that you said there. So this concept around mnemonic passphrases, it's just a list of keywords. They follow a spec. It's called BIP 39, if you want to Google it. Essentially, what it is a way by which it generates what's called the seed of a private key. So you can generate an infinite number of addresses from that. That's a nice kind of way to help people remember private keys, because 137858899 is not exactly very easy to remember. All right, so we've got some more questions here which I wanna tackle. So first is, if private keys are so valuable, doesn't this make them more susceptible to being targeted by malicious actors? And the answer is obviously yes. But here's another factor that is relevant in there. Typically when someone is targeting people for their amount of money they have in their bank accounts, etc., it's because they like flaunted their wealth or something. Maybe they're driving around in a Ferrari or something like that, or they just know that this person is like a famous celebrity, they have lots of money, etc. On blockchain with crypto, they don't need you to be actually doing anything. You can just look at the accounts on there and see what the current balances are, because that's all public information. And if it happens that you have, for example, today, these days, you can sign up for what's called an ENS, Ethereum name service, and give it a name. So people then give their account a name and then use that name on Twitter. Well, now it's super simple for me to go look at who you are on Twitter. Maybe that's your real identity. Go into Etherscan, which is sort of a public blockchain list of all the transactions. It's called an explorer. And go look at your account and see what your current balance is. And so then you might become a potential target for all kinds of malicious activities. Now, the malicious activities in this case are basically things you can do in real life. So figure out where you live and hold a gun to your head and say, give up the private key, etc. But so you can then become a target like that. So be a little careful about that. Like, it's great about saying, oh, I'm part of this DAO and Web3, and that's how I'm going to put my address out there, etc. But if you've got a large balance on there, etc., you are a target. I mean, it's just no two ways about it. It is risky. So
and I was gonna add to that, if I may, is before we were putting that information out there already, because we tied so much to our email addresses, because that's how we authenticated in Web 2. So Elon at Tesla.com, that was the same target previously, but you knew exactly who that person was. You knew it was Elon, versus now you see an address. Well, I still don't know that it's Jonathan Shealy's address. I just know that this particular address has money. So one of the nice things about wallets, that you can get into is being able to create from the same mnemonic multiple addresses. So at any time, if you want to separate yourself into personas, as it were, and which is what I think in the real world most people do. Most people have a work email address and they have a personal email address. Well, you can do the exact same thing with wallets, where you can have your personal address and you can have your work address, and you would use them differently. And I do want to touch on one other point about that. We can talk about that later, but as far as development and how that helps you. But if you want to dive into the next one, Nick.
Yeah, there's a couple of things I wanted to cover before we leave this topic. We talked about securing private keys, etc. There's lots of ways to do it, but the best way is what's called a paper wallet, where you've written that private key down, printed it out on a piece of paper, and then you can store that somewhere in your bank locker or wherever. That's always a good way to do it. But there's also this concept called Shamir's secret. I will post a link to that. Shamir's secret is essentially a system. It's a secret sharing scheme in cryptography. And what it does is it allows you to break up that private key into multiple parts in such a way that you can specify. So let's say that you break it up into 6 parts. You can say that you need 3 of those to be present to reconstruct the key. You don't need all of them to be present. That's the beauty of the Shamir's secret. You can also say that you need 1, meaning perhaps you, assuming you're not dead, and these 2 and at least 2 others to be present in order to be able to recover the private key. So Shamir's secret is a great sort of scheme that allows you to distribute your key among lots of people and be able to recover it, where you don't have to be worried that, oh, one person is going to just have my private key and then they can just go do harm. It would require multiple of them to collude in order to recover your private key. And if you specify that one of those people is either you or someone, your spouse, or someone super trusted, then you can guarantee that all of them need to be present. So, we are at this point right now in crypto where there's adoption happening. We are still super early, but all these real world solutions around what happens when you're dead, basically that is a fact of life. What happens, etc., is not all sorted out. It's only, I don't know how many years ago that, for example, Facebook and Twitter and all that came up with sort of memorial mode where someone's dead, and so now their account goes into, stops suggesting that you should friend this person or whatever, in a very bizarre and macabre way almost. So these private key problems are going to be sorted out. There needs to be tools for them. The other thing is, in a business scenario, you don't want to have one person have the keys to the kingdom, if you will. That private key, if you have all your assets in the corporate treasury, and one person has access to it, that's unacceptable. So the solution to that is to use something called multi-sig, which literally stands for multiple signatures, and it does require multiple signatures in order to execute a transaction. And Gnosis is the most popular platform that does that, GNOSIS. And as someone said in the comments, it's really not changing the wallet scenario at all. The wallet is still one key signs one transaction. What Gnosis does is essentially make a hidden, well, it's not hidden, it's shown to you, but the actual account is not the ones that the participants have private keys for. And it's an account where essentially the smart contract furthers and executes the transaction if the rule is followed. And the rule could be something like, there's 4 keys, 4 owners, and 2 of them have to sign it in order for the transaction to go through. So the smart contract acts as sort of a traffic cop for that. And that's a really useful way to have business support for treasuries and things like that. So I think that covers.
Super important for any DAO organization would be set up something like that for your board of directors.
Yep. Yeah. So that actually brings us very neatly into our next question here, which is, what are the suggested solutions around using, wallets as authentication and authorization for APIs, something similar to Auth0? Let's talk about, do we need something like that? And how does authorization work in Web3?
Yeah, so it's one of the actually notes I had, which is, off zero in itself, like as a service, really great for Web 2, right? As developers, I've written so many login providers in my time that I hate. I can't stand doing them anymore. It changes literally every time, the libraries you use, the way the systems interact with each other, the URLs change constantly. And if you're ever trying to build it locally versus, for production, if I'm a developer, it has to point to my, ping back to my computer. Well, but it's a local host address. How does it ever do that? That's really problematic. In this particular world, which is for developers, is one of the key points I want to mention is your wallet is your address and you are signing that transaction. It is the same if I am in development or in production. It's the exact same key, exact same address, everything is the same. And it's just up to my API to verify that that signed transaction coming from this user is the same one that signed it. And that's it. That's the authentication model. It's completely driven by the user's capability of signing that transaction and the server just verifying it. In the version that we have in the web nowadays is when we do OAuth or Auth0 uses like a JOT token, JWT, JSON Web Token. That token is essentially your signature that is signed with private key encryption, but it just so happens to be done by Google or someone else that signs that step for you. Now you're doing the signing of that same thing. So you're signing, but not only are you signing the transaction, or excuse me, in previous terms where you just sent your pre-signed web token and the transaction as two separate things, and then the server decided to make sure that it was the same person that did this. Now you take that transaction, you sign it, and then you just give them that bundle and say, do this. And then that API is the one that just verifies. Its only job is to verify that this is, coming from the person and passes it on. So it streamlines that API process so that you don't have to write any of that code. It's all handled by the user who signs the transaction.
Yeah, can we dive a little deeper into the authorization aspect of it? So from a smart contract perspective, what does authorization mean? So you've got maybe you've got a function that's like transfer NFT or whatever. What does authorization mean in that context?
Good question. So authorization means, I'm not sure I totally follow the question here, but
I can take a stab. I mean,
yeah, I was going to say ultimately the transaction would know, when who originated this particular command. So therefore you can validate the address that they're putting in there is the person who originated the command.
Yeah, I mean, so that's basically the high level of it. What I was getting at is that it is the developer's responsibility. They know who the signer of the transaction is, who's calling it. It's your responsibility as the author of the smart contract code to determine if they should proceed with that. Are they the person who should be allowed to do that? And honestly, a lot of the hacks that you've seen in smart contracts, etc., they occur because a developer did not pay attention to that particular aspect, because it is entirely possible that the calling account is not a person, it's another smart contract. And that smart contract might have been designed to essentially leach all the funds out or something like that. So that is an actual very, very risky thing that occurs, especially, given that this is so new and many developers are just getting into it. They don't know a lot about it, and they make that common mistake. So let's talk a little bit about, we talked about Web3 and MetaMask quite a bit, but we don't do nearly as much casual sort of surfing or browsing, etc., on desktop. That's more done on mobile, right? A large part of our experience on the internet is on mobile. How does that work? Let's say for MetaMask, how does that work?
Sure. So MetaMask is on mobile as well, which is really nice. So you get, like, again, I had mentioned some extra benefits for security because my phone has Face ID. So in order to even be able to access my wallet and, ultimately my funds, I, Face ID and PIN code. So the device handles a lot of that. And with, Apple, it happens to have their secure enclave to even be able to get into that type of information. And then your private key is stored in there, which is super nice. Um, the beauty of that when it comes to authentication and what Web3 provides that we didn't have in the old world is because now it is on my phone and it is something that I own. Systems like we haven't mentioned yet, but like Wallet Connect. Wallet Connect with Ethereum and other services allow you to like scan a QR code and then it communicates back to my device. So I scan that and say, yep, now I sign a transaction that says who I am. That now allows us to bridge between the web and my phone and prove who I am. But I can also do that in the real world. So if I am at, Starbucks or something like that to get coffee and they have, you want to sign a transaction, they just can spit up a Wallet Connect. I sign that and pops up on my phone. I say, yep, approve. And now I've just bought my cup of coffee in one click. And now that wallet, all that transaction happened with my device. I didn't need, Visa, MasterCard, anyone in between to take any percentage. It's just a simple, the device at the, counter just popped up a QR code with my transaction QR, and that's it. I just scanned it and I'm done. That's something that we can now do using the same technology and the same authentication process that we use to sign into any website going forward, the same authentication system that we would be using to prove that our API when we send our transactions all the way down to the contract to prove that I am who I am in one shot. Same code base, very simple API. It's like one little tiny function to add to my code to make that happen. And now we just bridge the gap between the real world and, the digital world.
Okay, so we introduced some new concepts here. I would like to just dive a little bit more into it and elaborate because I think it's worth explaining Wallet Connect and how it works. So what is Wallet Connect? It's essentially a protocol that allows, it started off solving this Web3 authentication on mobile. That's where it started, but it also works on desktop. But essentially, Wallet Connect is a standard protocol, and all wallets that conform to it, and all dApps that conform to it. So there's two sides of the equation. Your app, whether it's a web app or a mobile app or whatever, that uses Wallet Connect. And then there is your wallet, which also supports Wallet Connect. So it's a many-to-many scenario. As long as your application supports Wallet Connect, it can work with any wallet that supports Wallet Connect. That's the whole beauty of it. So a developer who's building an application doesn't have to specifically code for MetaMask or Rainbow or whatever other wallets are Trust, etc. So they just conform it to the spec and that works. And the general workflow, as John was describing, is that you're on desktop and your wallet is on your mobile, your MetaMask is on wallet. When you go and use Wallet Connect as the signing mechanism and you say desktop, it's going to show you a QR code. You scan that with your mobile device and then it takes over from there. The question I have for you, John, is how does that magic happen? How is it that there is this QR code and that scan and miraculously just shows up on the mobile? Because in order for that to happen, there needs to be a centralized service. Something has to be in between there. What is happening there?
Now I forget exactly how Wallet Connect does its protocol, but I believe it uses WebRTC, peer-to-peer connections to do that. It uses like a WebSocket connection to make that from my device, specifically from my device to that browser or wherever the QR code's being displayed from, if I recall correctly.
Yeah, so essentially what it's doing is it's opening up a central sort of on the fly communication point, a hub, if you will, between the app and the wallet, because they are two disparate systems, who knows where they are. And now the Wallet Connect thing is there, which is exactly why it's not 100% reliable. Like, I don't know about you, but I have been on, I do a lot of transactions on OpenSea. there's many times we have to repeat a transaction 5, 6, 7 times before it actually works, because it's still, it's new, it's evolving, it will stabilize over time, but it's definitely not like bulletproof totally yet. So, we've been talking a lot about Ethereum and MetaMask, etc. Let's talk a little bit about another blockchain, like maybe let's talk about Flow. So on Flow, you don't use MetaMask, you use a wallet called BlockChai. How does that work?
Yeah, so BlockChai is more of an analogous to Auth0 in the sense that you create an account with them, with the BlockChai service using your email address, which you can create multiple of them. But that they hold your private key for you. So you're trusting that service just as you would trust Google to store your password and all of your data with that. And I think the proper term for that is a custodial wallet, as they say, which just semantically means you don't own the private key, they do for you. So this is analogous to just doing a quick little detour back to Ethereum and stuff like that, or is Coinbase. Any centralized exchange that you would work with is ultimately, they have the private key for any of those addresses as far as your on-ramp there. BlockChai is very similar to that, which is their custodial wallet. They control your private key, and you just log in as a normal username password type scenario to get access to that, because you're trusting them to protect your private key. And their service works both for development in the web browser as well as on the phone. Which is, as we go forward, the original ones were, basically all just Chrome extensions and stuff like that. But as the technology has matured, almost all of them have a phone variant because of how useful that is to be able to, sign transactions on the go. And, when you see something you like and you're out in the train station or something like that, I just want to buy that NFT real quick. You don't want to run back to a desktop to be able to do that. So bridging that gap, but now that they're on the phone, you can do that. Now this is very similar to the different other blockchains. So for every blockchain essentially has their own wallet providers. Thankfully, some of the blockchains, you can use the same wallet multiple times, but like MetaMask or anything like that. But like Algorand uses their Algo wallet to be able to do them. So the newer blockchains may only have 1 or 2 options available for wallets, whereas the Ethereum, I think there's like 20 or 50. There might even be more than that nowadays. And you get to have that choice, which is, that's the benefit of it being it's an older technology. More things have been built for it, and you get the benefit of the experience of the design and things like that. So if you like that experience, you get to use whichever one you'd like.
Yeah,
they fundamentally all work the same.
Yeah. It's important to clarify something, and actually BZ did the same thing, is that some of these wallets do have the ability to start off as custodial, where they are holding a private key for you, but you can say that, I can manage it. And then you can switch to non-custodial, and they kind of, you get the private key. This is also a good point to talk and to use the phrase, it's kind of important, is not your private key, not your crypto. So what that simply means is a lot of people, maybe they have a bunch of crypto and they store it in their centralized exchange account, whether that's Coinbase or Gemini or Binance or whatever. You should not keep lots of money on those exchanges, because they are essentially centralized entities. When you put your money into a bank as we know it, you are trusting that bank. You are trusting that they will give you back your money when you ask for it. Why will the bank do it? Well, because they have some regulations and they have a government that makes them do it, and therefore they do it. With the centralized exchanges, those regulations are questionable at best right now. The exchange could be anywhere. It could be in a country that does not have those kind of regulations, etc. In the early days of crypto, we would have exchanges just disappear. All the money is gone. You have no way to recover that capital because you didn't have the private key for it. So you should only keep on centralized exchanges the funds that you need to support maybe some minor transactions, etc. The purpose of centralized exchanges is to act as on-ramp and off-ramp to fiat currency, meaning your US dollars and your pounds and francs and dinars and rupees and all that kind of stuff. Otherwise, the secondary purpose of it is to support trading, because what centralized exchanges do is they maintain an order book where there's sell orders and there's buy orders, and they match them. And in order to match them, they take a small cut. This is exactly how the stock market works, and that's the centralized exchange. But what's better is to use decentralized exchanges where everything is done on chain and you don't risk losing your money because everything is governed by smart contracts. So Uniswap, that's the canonical example of centralized exchange. That is better to use. Of course, you are welcome to just not put your crypto into any exchange and just leave it in your account, in which case, as we talked about earlier, if the money's just sitting there, you want to make sure that that private key is secure. A good thing there is to use a hardware wallet. In a hardware wallet, it's just a USB device. The private key is sort of encoded into it, and you can't leak it. You typically use some input buttons to enter a PIN code, or they might have a fingerprint or something like that in order to be able to transact. But it's a little more secure because it requires a physical access to a device, which is easier for you to control than your private key if you store it online or something like that.
Something you have, something you know.
Yeah. So security of those keys, etc., is very important. But I think a lot of people don't realize that on centralized exchanges, they really don't have anything. If they decide to just block your account, you're done. You have no recourse. And this also brings us to something you said earlier, John, about, okay, on Ethereum, there's like lots of different wallets, and that is happening on other blockchains also. But one of the things that people rely on those wallets for, and they like to do, is to look at all their tokens. Yeah, what are all the fungible tokens you have? And then you go to a marketplace like OpenSea or Foundation or Rarible, and you connect your wallet and you see all your NFTs. And I think to a person who's non-technical, that's just magic. Like, wait, what? How did that happen? I just hit connect. It doesn't matter which site you go to, and you connect and you do that. Hopefully in this session, having realized that your crypto, your fungible tokens, your non-fungible tokens are always just on a blockchain, right? So any app can be created that can be given an address and say, go look at the blockchain and find every transaction made by this address. And if any of those transactions are NFT transactions, show them. That's what's happening in the background. That's what's OpenSea is doing when you go and say my collection or whatever. All it's doing is it's going and looking at every transaction on the blockchain. It doesn't actually do it linearly like that. It's a very efficient way to do that, which is why it takes you a few seconds instead of days. But it just scans it and finds all the contracts to which your account has had a transaction and has ownership of a token, and it surfaces those. It's also important for you to know that you have all these drops with all these different NFTs, etc. They're all different contracts. Each of them is a standalone contract, and so it has to scan multiple contracts in order to find things out. John, did you have any more things to say on that?
Yeah, I actually had one more point, unless there's any questions in here. I think we
I don't
caught
see
up
any right now.
on those. Which was, so for authentication, authorization, but also gets into the which Nick alluded to, being able to find your NFTs from your address, is a little bit of the social contract, which is the history behind being able to do all of that system, because you own the authentication and we can prove that it's you, because you own that private key, as we talked about. The history of that particular address becomes very interesting to you and to others to be able to see, how you use the system, what transactions you've made, are you, do you have vested interest in these different tokens? People can provide you with, different resources because of that. So that can give you access immediately to, if I want to build that into my website that says everyone that is using the DAI token automatically just gets into my website because of that social history of what they have. And if they don't have it yet, they can go get some and then immediately be able to go have access to that. So giving a little bit of that social credibility is a nice feature, but also, you know, on the flip side of that, if you want to be anonymous and you don't want that social credit, just create another account. So being able to create, you know, pseudonyms or alias authentication accounts for whatever reason, as we talked about before, between just personal and work, you could create one for, you know, if you're a gamer, you can have that be your gamer profile versus your, you know, insert any other profile here. But which is really nice to have kind of those personas where, you know, you can kind of do that and have that credibility there without, you know, worrying about your day job or anything like that.
Great. All right, I think we are almost up with our hour here. I hope you enjoyed our deep dive into sort of and comparison of Web 2 and Web 3 wallets. I think it's a fascinating topic because, you know, one, Web 2 is so pervasive, millions and millions of accounts, and the other one in the low millions, still growing, but not yet mainstream. And it remains to be seen how wallets can improve their user experience to become more accessible to the layperson. So I was just going to say, are there any more questions? And there is one: what's the best way to continue this conversation? And are there any resources you would recommend? Thank you, Natasha, for that question. Yeah, so please, a great place to have this kind of conversation is to join us on the Decentology Discord. I will put that link right here. It's discord.gg/Decentology. We are happy to have these conversations. Of course, John and I are both on Twitter. I'm at TechBubble, and Jonathan is at JSheely. But we'd love to continue this. And of course, we are going to have BlockChai and Chill every week, and we might go even deeper into this topic at some point in the future. There's one more question here. If the purpose of connecting your wallet is to give the site a public address and verify you have access to the account, could there be a potential use in doing something like what PayPal does in verifying your bank account, like send a small amount of funds to your account and transfer it back? It's a good question, but I don't think it's necessary. The reason is because read is public in blockchain. And so anyone can read anyone else's account. So by connecting, all you're doing is saying, filter out everyone else's crap and just show me my stuff. When it comes to proving that you can actually do something, a lot of open marketplaces, for example, have you sign a transaction. This is what we talked about earlier. It is not possible for an arbitrary person to sign a transaction and then have that being validated as your address. So if you see, like the first time you connect with a foundation or something like that, you see a sign dialog pop up, it's just doing that. It's verifying you, but it doesn't have to. That's a nice to have. You only need to sign when you're actually changing data on the blockchain. But that concept of putting your two small deposits that PayPal, etc., do to verify you, the first dialog you see when you connect with a marketplace and it says sign, that's exactly what it's doing. That's the analogy of it. So it can validate that you are in fact the owner of that account and you didn't just make it up.
Yeah, and I would say in a DAO model, that's actually what PayPal does with the 2 cents and stuff like that is still probably a useful model, because if, you know, you're getting your paycheck in the form of that address and you give someone your public address and they're like, oh, well, here's $10,000. And they send it to the wrong address because they copied and pasted the wrong one somewhere along the lines. You know, then you may or may not be able to ever get that money back. Yeah. So it's helpful to do something like that, be, you know, having a process be like, all right, we put 2 cents in there. Do you see it? Is it in your transaction? Yep. Okay, good. Then sign that back and say, yep, you got it. And then the process would actually start to be able to, you know, fund your wallet.
Well, I want to thank everyone for attending this episode of BlockChai and Chill. We had a lot of fun, a lot of information we talked about here. Hopefully it was useful for you. If it was, please do let us know. You can go to @Decentology and talk about it there, or you can go to my Twitter @TechBubble or @JSheely. Thanks. Have a wonderful day, and we'll catch you again next week. Bye-bye.